Let's take it away, Joe.
Okay. Thank you. Hi, everyone. I'm Joe. I use Grafana all the time, just like our previous speaker. I'm not actually going to talk about Grafana today, though. I'm going to talk about a DevOps cultural practice, I guess is what I'd say, that I'm very passionate about. I work on a product that helps people use it, but I'm going to talk about the concept in general. Like we said in the intro, I have been building big distributed systems for almost 15 years now. I'm getting on in age. And in that time, I've been following a very sort of DevOps practice in doing that, which means, I'm responsible for the operation and the quality of those systems, not just the quality of the code that goes out, but are they configured correctly? Are they running right? So I've been on call with them. And I love that because it means my team is generally more effective. But I hate that because it means I get paged at 1 in the morning, right? It doesn't happen often, but it happens often enough that it can be really troubling and very stressful. So I want to talk about that a little bit, about what being on call can do to you and for you, and a methodology that can help make that experience better, which is called service level objectives. Talk about how to do those right, and how alerting works in an SLO context, and why it's a nice improvement over what you may be using if you're already doing a sort of DevOps workflow. So burnout is a big problem in the software engineering world. It's something that causes people to quit jobs, which causes software teams to fail, which causes companies to fail. And a lot of us experience it from time to time. In some point in our career, I would bet almost everybody experiences symptoms of burnout. And people are often in some places a kind of low-level state of this all the time. This is a common problem in the field. And I believe that on-call is a big source of this, because things that cause burnout are having unclear expectations of what your job is, not having autonomy or control over what your work is, right? Like being micromanaged, not being able to unplug from work, you're always on the clock, and not being able to actually finish your work. And a bad on-call culture can cause all of these things. Who's responsible when an alert goes off? Can I do anything about it? If I'm paged often in the middle of the night, like an emergency room doctor or a software engineer, can't really unplug from your work, and that leaves you in this sort of high cortisol state of stress. Not being able to ship because you're working on alerts all the time. I realize I have 2 mics. Oh, I do need 2 mics. Never mind. I understand. No, it's fine. I don't mind. Not being able to ship comes out of bad on-call culture too, because you may just be doing alerts all day, every day, turning up the RAM, looking for the network configuration, and that causes burnout too. So when on-call is useful for us, it's because we get the alert to the right person to fix it. The alert is meaningful and actionable, which means you can do something about the source of the alert. And what you're getting paged for is real, right? It's actually something, and it's not just false positive, like we've set a threshold too low and I'm constantly getting alerted when we cross some line. So things that are too frequent don't mean anything. These up our on-call stress and put us in a bad state. So I'm going to talk now about that methodology I mentioned called service level objectives, which is a great way to kind of get out of that state and into a on-call workflow that can be better for you. Because service level objectives help you understand what's the most important thing that users of my system need, right? I'm on call for this. What am I actually expected to provide and at what level? How do I measure that effectively? And then how do I alert on that effectively by understanding the health of the system that I'm responsible for? So SLOs help you prioritize understanding that, alerting on the most important things, and even planning your work based on that state of the system. There's 3 words, but it's really 2 concepts. So service level objectives imply a service level and an objective. The key point here is that service here does not mean microservice or service-oriented architecture or anything like that. We mean service level, like at a nice hotel or a restaurant, they have a high service level. In a software context, service level is what are you providing to your users and how good are you at doing that? So you need to understand what they want out of it and how you measure that that's actually being provided. When I talk to teams or my own team about how to define what that service level is that we're measuring, I like to start with a story. Can users sign into our app? Turn that into what we think a metric would be, like login requests. Do we have that metric? Let's make sure we can get that metric. And then writing a query that returns a number between 1 and 0, or 100% and 0%. So in this case, we're looking at our login requests succeeding, that status code is not 500 something, and in less than 2 seconds, right? This is a Prometheus histogram metric that we've set with these buckets, divided by the total rate of login requests. So this is giving us how many successful logins as a percentage have we had in the last 5 minutes in that query. That's how we go from like, can users log in, to now we have a number. And this is like a really key step in figuring out SLO, is figuring out this indicator. It deserves some care and time. Some really common indicators are success rate. In fact, red metrics are a really great starting source for defining SLOs, right? An error rate, a general like sort of request throughput sort of condition. You may have expectations about how much you're able to push through a job, right? If you have a sort of continuous data processing job, you're gonna want something more like successful and throughput compared to just like successful things done. And latency or other sorts of measurements of the statistical shape of your system. Like this, like the 99th percentile latency is below 500 milliseconds, which is telling us the vast majority of users are getting service fast enough, however you define that number of fast enough. The second concept is the objective, which is what level of quality is okay. If you ask your boss, he's going to say 100%. Why can't we just serve 100% of requests correctly, right? Like, hopefully your manager is a little closer to your work and understands that that's an impossibility. But the objective is a target between 0 and 100 over some time period. A month, I like to use 28 days because it eliminates the like, these months have more days than this month kind of problem, and accounts for some sort of weekly variation in requests that you might have. 7 days is another really common kind of target, like we want to hit 99% in the last 7 days measurement. This is why we can't serve 100% of requests, by the way. So this table lists out, you know, if your service is operating great, 100% all the time, but then you have hard downtime, 0% success for a certain period of time, how long can your system be down and you still hit your objective? Well, over a month, if you're trying to deliver quote unquote 5 nines of reliability, you've got 25 seconds of downtime available to you. So you need to have some really sophisticated automated recovery built into your system if you're going to try to deliver that level of quality. The point here is to, you know, convey that to be realistic about what we can deliver, we should be realistic about what our customer expectations are too. 10 minutes of downtime for an e-commerce application might be really, really bad, but 10 minutes of downtime for an internal developer platform might be okay, right? So there's a sort of, you need to think within your organization, within your team, about what's a realistic expectation of quality. When people first start doing this, I usually advise start low, look at where you're at, ratchet it up until you're starting to feel a little bit uncomfortable. And then that's going to motivate you to improve your system, deliver a higher level of quality over time. And another thing you can do, of course, is look back at your measurement over the last few months and find out, you know, what is my sort of average delivery thing here. A key thing is like that top-down objectives don't work for a company or team or whatever to succeed at doing this. If your boss, well, there's 2 parts to this, but internally, if your boss just says everyone's going to do 99.9, some people are going to be fine. Some teams are going to be in a kind of a rut, and what is most common then is that people kind of sweep it over, kind of game the metrics, kind of, you know, just avoid actually doing it. What people need to see is that using this kind of methodology makes my work life better, makes my software quality better, makes my customer experience better. And so you need to start somewhere and ramp up rather than, oh, we're all going to do SLOs and we're all going to set this objective. It really doesn't lead to a successful approach to this. After you get an indicator and an objective, we can start talking about alerting. So we're monitoring based on our user symptoms. And at this point, we're going to start alerting based on when those user needs are not being met. The point to get across here is that alerting is for emergencies. You're gonna wake somebody up at 3 a.m. because things are really broken, not because things might be bad in 4 hours, right? Alerting is not like maintenance. Your system deserves maintenance, but you should be doing that as part of your normal workday, right? You should have dashboards that are measuring resource usage and costs that you're incurring as you run software. But those are things for you to look at during the workday. Things for you to look at 3 a.m. are, we can't sell socks, we can't sell shoes. Not, it's costing us 10% more than our goal to deliver that. So we'll talk a little bit about alerting math to make sure you get alerted at the right time, not too early for little tiny blips, but not too late that you can no longer meet your objectives by repairing your system. To talk about that, I want to talk about our budget. So if we set a 99.9% objective for SLI, then that means 0.1% of our requests over that time period can fail, right? So we can talk about that as a budget, just like a cash budget, and you can burn that budget, just like you can have a burn rate on your cash budget at a company. So we're gonna talk about the error budget burn rate over the next few slides. When you're spending your budget too quickly, you need to pay attention. If you're spending your budget and you'll still be ahead of your objective by the end of your period, there's no reason to be alerted. You do your system maintenance as a normal part of your workday. So in SLO, I like to talk about sort of 4 levels of alerting, which is, it should wake me up because there's extremely high error budget burn happening, hard downtime in the system maybe. There's like, I should look in the morning because maybe in 4 days I'll have used up all of my error budget, right? If things continue like this. There's, we shouldn't alert at all because there's just some little blip in errors maybe that happens. Or there's like, you know, we should do this as part of our normal maintenance of the system because there's some low amount of error burn happening. Translating that into some math, we like to basically measure the burn rate over a few different intervals and then combine these into alerting rules to alert. So measure your SLI over 5 minutes, measure your SLI, sorry, your indicator is what the word I've used before. Measure your indicator over 30 minutes, 2 hours, 6 hours. Then also measured over these longer time periods too. And what we do is combine that short time period and that long time period into a single alerting rule and compare it to this threshold, right? So for very high error rates, we want to measure, is there a very high error rate over the last 5 minutes and over the last hour? What that does is that if there is a super, super high error rate in a short time, we'll get alerted. If there's a somewhat high error rate in the last hour and the last 5 minutes, we'll get alerted. But what we won't get alerted for is one really quick blip that gets above 14.4 but goes back down very quickly. And that's the idea behind all of these, is that we avoid getting an alert for some transient thing that happens and then goes away and now there's nothing to do because the thing has already resolved, which is a terrible thing to see at 3 in the morning. It's a great thing to see and take a look at 10 in the morning when we're on the clock. So that's why we have these different levels of severity. At my work, urgent and high goes straight to my phone, right? Like I get a Slack message and I get an SMS. Moderate goes into a team Slack channel and we take a look at it if it's happening during the working day or during the next day when we wake up. And low also goes into Slack, but with like no mentions or anything like that. We kind of pick it up as part of a regular sort of grooming of things we've seen come up, right? Like in the weekly team meeting, we'll pop up how many of these did we get? And do they mean anything, do we think? Should we look into this more or should we table it and set it aside? So having those different levels of severity for the same measurement can be really effective. And even in a non-SLO context, I think these kind of alerting measurements can be really effective because it's not just like one measurement, set a threshold, get an alert, right? Little blips will cause you problems. So these measuring the same things over multiple time windows and only getting an alert if it shows up in both time windows can be a really effective way to cut down on noise, but still get alerted for serious problems. So even if you're not looking at a service level objectives framework, I would encourage looking at alerting rules and seeing if there's some way of doing something like this, because it can be really helpful for your team's sanity. You can also, once you've got all this kind of stuff set up, look back over time at your alerting rate. This is part of the product that I work on. So like, full disclosure, this is not open source, but this is just a Grafana database, or sorry, a Grafana dashboard. You can download it. But this is in our demo environment. But we have this really noisy, kind of junky front end system here, right? Where we have a lot of errors happening all the time. We can see the success rate bounces around, right? Somewhere above 97%. But the other thing you can see here is that over the last 7 days, our actual measured indicator is 99.81%. We're still well within our error budget. And all of these little error blips are quite low. So we're actually performing as we expect. And that might look like a really bad chart when you look at it, but people are being served at the level that the team has decided is acceptable. And maybe you want to ramp that up over time. But so there's no reason to get alerted. We still have 73% of our error budget remaining, towards the end of the window. So the team's in good shape, even if that graph looks kind of bad. And that's kind of a nice thing about this approach, is that you're really getting that final number coming out the end, and not just, oh, at this point in time it looked bad. I think that's a key thing about service level objectives. And this is the kind of dashboard anybody can put together once you get that indicator measurement. Okay, so to wrap up, talked a little bit about what a bad on-call looks like and why service level objectives is an approach that can help you improve that, how to make service level objectives that make sense, and what that does for your alerting. Thanks very much. We have some time for Q&A if you want. Shy group.
Thank you for the talk. So the question is basically, it's not just that we need to call people in the night and be down, but usually it's not enough, right? Let's say there are some situations in some systems and that if something is happening in 4 hours, your system will become offline, right? So what about alerting these such cases? Like, then system is still available for the users, but you become on the timer, basically to fix it until to pick up that.
So an example of something like this might be, I don't know if Genny, if you have one in mind. I'm just trying to think of an example of something like that where I might see it.
For example, you have a disk space, and this space is filling up in a rate that in 2 hours the service will just have out of disk space and go down.
Mm-hmm. So I think you can hammer that into an SLO type framework if you wanted to, but you could also write alerting rules that make sense in that sort of approach. But I guess is it something where you have a steady state expectation of the disk space? For example, if you just sort of expect disk usage to be relatively flat, 25% or something, right? Because you're just using it as a write-ahead log or something, right? And you don't want it to go up, then you could write an indicator that says something like, well, we expect the disk usage to basically be flat and below some percentage, right? And as you go up above that, now your indicator starts to look worse and worse, and that can trigger these sort of SLO type alert rules, right? So you could, I want a worksheet almost so I could write this out, but you might set something like disk usage below 0.5. So it might be, you'd want something that says like the difference between full and half full or something as your measurement, right? It's always 1 if you're below 50%, and then it gets worse and worse and worse. And then you might set an objective of 99.9, right? So once you go above 50, you're going to start to lose error budget pretty quick, and then you should get paged. You still should get paged at a late time. Sorry? You could, yeah. I mean, I think for the indicator, you can start to get really exotic, right? If you understand your system well, you can write some really complicated indicators as long as they make sense. And you could write it in such a way, right, that if it's hovering at 51%, just because it's above 50, hopefully you don't get alerted for that. But if it's hit 50 and it's heading up towards 60, then probably you should get alerted, right? So having that, the slope of that line is sort of incorporated by the distance between, you know, as that number goes down further and further towards 0. So I think you could actually fit discus filling up into that framework if the rate of it filling up starts to look bad enough.
Thank you for the session. For us, it's a starting criteria about SLO. So what do you think is good starting for that?
I think a few really good starting points. Is it a web system, right? If you're serving requests over the web, I think just some really good ones are just like, let's take all of our API endpoints, measure the success rate of hitting those. These are usually like the important things that your end users care about. If you can derive red metrics from that, looking at the error rate, I think is the most straightforward one, or looking at the error rate combined with the latency. I think those are usually really good starting ones. Oh man, yeah. So I started working on SLOs as a product almost 3 years ago now, and we were already using them internally at Grafana, but it's very gratifying to see it expand for sure.
Any more questions? Thank you, Joe, for speaking about SLOs. Hopefully we can implement them and organize it. And now